Radical versions of physicalism fail at the level of our intuitions. I don't mean to suggest by this that our intuitions are the last word on what can be accepted as true or false. But we do rely on these intuitions where neither the force of logic nor the evidence of sense supports one account at the expense of all other accounts of complex phenomena. Thoughts are not like things, and feelings have no shape. This is sufficient for most persons, even keeping an open mind, to regard the physicalist agenda as excessively optimistic, if not grandiose. That such a judgment might be premature has been suggested by more than one philosopher. Galen Strawson, in his book Mental Reality, argues that the real problem with physicalism is that we simply don't know enough about matter itself. He calls himself an agnostic materialist, and he puts his position this way, quote, "According to agnostic materialism, the idea that the mind-body problem is particularly perplexing flows from our unjustified and relatively modern faith that we have an adequate grasp of the fundamental nature of matter at some crucial general level of understanding, even if we're still uncertain about many details," close quote. Galen Strawson remains committed to monism, to monistic physicalism, but he must remain neutral, or as he would have it, agnostic, as to just what the physics of it all might in the future turn out to be. I regard this as a properly modest position to take. Although the age of Newton, not to mention achievements in the ancient world, have supplied us with detailed knowledge of the physical world at the macro level, it is important to keep in mind that at the micro level, at the level of particles, the science of physics is a fairly young subject. It is not only young, but by historic standards, entirely surprising. I'm not sure how physicists prior to 1900 would have reacted to the fact that, for example, the neutral B meson goes from its particle to its antiparticle state at a rate of some 3 trillion times each second. They never faced such a challenge, in part because the measurement of events occurring at such a rate was simply impossible. And what might they have said about there being 6 flavors of quarks, not to mention a strange quark into the bargain? In all, then, the expectation that physics will provide an increasingly detailed and perhaps ever more surprising account of the material world is sound and sensible. It would also seem safe to conclude, even at this early date, that if consciousness ever proves to be something finally and ultimately physical, it surely will not be that at the macro level of chunks of brain tissue, but at the level of subparticles. Accordingly, if the physicalist is to press on with attempts to ground consciousness in physics, there's good reason to believe that it would be quantum physics that would have to do the job. I will return to this later in this lecture, but I want to consider first some reasons for doubting that our current understanding of physics is up to the task of explaining conscious life. The future will speak for itself. I must be cautious here, for the easiest way to don the fool's cap is to declare as impossible what science often in a matter of decades or even years shows to be nothing less than inevitable. When we modestly suggest that a particular and only quasi-scientific perspective on an issue may prove always to be insufficient, we must make clear that our position is based on some sort of conceptual analysis, and not on the facts and methods of science as such. The distinguished Oxford mathematician and theorist Roger Penrose may be said to have put the ball in play with 2 extremely interesting books. The first titled The Emperor's New Mind, which appeared in 1989, and the second, Shadows of the Mind, which appeared in 1994. Both of these works seek to set limits on the extent to which contemporary physical science may be viewed as promising in relation to the problem of consciousness. The works are not at all pessimistic, but they are realistic. As with Galen Strawson's view that we don't know enough about matter itself, Penrose's position, based on an exacting analysis of physics and its mathematical foundations, reaches the conclusion that the phenomena of mental life may require a physical science, an entire physical science, not yet at hand. The issues here are complex, in some instances far too intricate to be covered in a general lecture. Perhaps I can convey at least the main points leading Penrose to the conclusion he has reached. We might best begin with a proof in mathematics known as the incompleteness theorem, and advanced by Kurt Gödel. He published his landmark contribution to mathematics in 1931 in an article titled, quote, "On Formally Undecidable Propositions," close quote. The generalization arising from his analysis can be expressed this way. Any mathematical system of sufficient complexity to include an arithmetic will be based on axioms and theories that cannot be proven within the system itself. In other words, the system is logically incomplete. Arguments external to it must be imported in order to render it complete. Now, in light of Gödel's theorem, Penrose concludes that the proper model of human cognition could not be computational. For if the essential nature of human thought were computational, the limitations imposed by Gödel's incompleteness theorem would be manifest. Well, this was manifestly not the case with Gödel himself, nor is it the case with the rest of us once we have Gödel's theorem explained. Clearly, and by way of our own conscious life, we are able to reflect on our own problem-solving maneuvers without importing into our system some set of axioms otherwise unknown to us in order for us to make sense of what we are thinking. To say that we do not need such an external problem-solving apparatus is to say, among other things, that the essential character of human consciousness is, technical term here, non-algorithmic. Taking the term algorithm as referring to a set of problem-solving axioms, we conclude that our own conscious achievements are, as I say, non-algorithmic. Is human thought the only form of non-algorithmic process? Not at all. But if we search through the vast realms of the physical, what we turn up by way of other non-algorithmic processes are just those that are described as random. Now, whatever we might want to say about our own conscious resources, we surely are not so modest, may I say not so crazy, as to regard them as random. Were it otherwise, there couldn't be a Roger Penrose, or for that matter, an audience able to comprehend his work. Let's put all this together. Penrose reaches the conclusion that mental life is simply not explicable in terms made available by the physics now on offer. But might the physics we have at least rule out alternatives to physicalism itself? Many think so, and they defend the judgment by invoking the first and second laws of thermodynamics. The party is getting rough, as you can see. The first law expresses the conservation of energy, establishing the equivalence of heat and work. Stated briefly, the first law establishes that the internal energy of a system is equal to the heat added to the system minus the work done by the system. If we express this as an equation, the statement is delta U equals Q plus W, where delta U is the change in the internal energy of the system, Q is the heat added to the system, and W is the work done by the system. Of course, to insist that the term for and the concept of energy is reserved solely to energy in its physical form is simply to assert physicalism, not to establish its adequacy. It would be a form of question begging. When we say that one side of the equation for the first law of thermodynamics contains energy, we are not required to commit ourselves as to the nature of the energy in question. Perhaps I might be permitted to invoke the notion of psychic energy. Gads, hopeful that this would not commit me to the care of a psychiatrist. Well, let's just agree that there could be some sort of energy of a type that would vindicate dualism or mentalism. Its very nature is such that our devices for detecting and measuring physical energy will never be affected by this form of energy. Nonetheless, let's say it does enter into the equation for the first law of thermodynamics. Let's call it M for mental energy. Well, we now might modify the first law to say delta M plus delta U equals Q plus W plus M. To the added heat in the system, we've added some mental energy on the left side of the equation, and when all is said and done, the system has used all this to do some kind of physical work, W, and yes, some mental work, M. We can all be content that the equation works. The first law of thermodynamics is obeyed. We should be happy. Is all this weird? Yes. Is it ruled out by the law itself? No. Everything balances on each side of the equal sign. The law is honored. As I noted, the law can be entirely neutral as regards the form of energy, though legislative in requiring energy if work is to be done. Well, now what about the second law of thermodynamics? What the second law asserts is that in any closed system, if anything physical is brought about, it is at the cost of energy in the system. James Clerk Maxwell, in his theory of heat, summarized the second law this way, and I quote from Maxwell: "It is impossible in a system enclosed in an envelope which permits neither change of volume nor passage of heat, and in which both the temperature and pressure are everywhere the same, to produce any inequality of temperature or of pressure without the expenditure of work." Close quote. We see, however, that our modification of the first law will work here too. There is still another conception of the second law, here expressed in terms of entropy. Some know the second law best in the language of entropy. In this version, the law requires a constant increase in the entropy of closed systems. How might we conveniently picture entropy? The distinguished physicist Richard Feynman, who was able, it seems, to see the world of abstract theoretical physics as if it were a collection of visible objects right in front of him, offered this way of understanding entropy. Imagine a closed system made up of a large number of tiny cubicles, each of them able to hold a molecule of gas. Let's say that we've been able to introduce gas molecules into that volume, and that the gas molecules are either black or white, but in equal number. Consider now the ways these might be arranged. In his lectures on physics, Feynman then brings the example to its informing conclusion. He says, quote, "If we have black and white molecules, how many ways could we distribute them among the volume of elements so that white is on one side and black is on other? On the other hand, how many ways could we distribute them with no restriction on which goes where? Clearly, there are many more ways to arrange them in the latter case. We measure disorder by the number of ways that the insides can be arranged, so that from the outside it looks the same. The logarithm of that number of ways is the entropy. The number of ways in the separated case is less, so the entropy is less, or the disorder is less." Close quote. Unaided by external influences, the molecules will distribute themselves randomly. Thus, the entropy will tend to increase. Now, to oppose this, work must be done, and it must be supplied from sources external to the system. Well, we begin to see what troubles physicalists about the idea that mental events bring about bodily events. To have such an effect, the mental events would have to supply energy, and this would be a measurable property of the system. How many mental ergs or joules are required to raise an arm? Needless to say, if the argument from thermodynamics were that straightforward, the case for physicalism would be essentially won, for the only plausible alternative to it would then be seen as simply impossible. Well, matters are seldom this simple. The thermodynamics argument is less than convincing for several reasons. First, in purely formal terms, as I've indicated, the thermodynamics equations are absolutely neutral as regards the nature of the units on each side of the equal sign. All the law requires is that the sums come out right, whatever the chosen units prove to be. Well, let's just suppose that there is some form of purely mental energy causally associated with bodily movements. Let's call the units of this energy mentons. The thermodynamics laws do not rule out mentons. They merely require that at the end of the event in question, all the mentons can be accounted for. If the thermodynamics laws are obeyed, there cannot be a greater number of mentons after the work is done than there were before these mentons acted. That none of them will activate a voltmeter has nothing to do with it. Opponents of physicalism have already concluded that the world of volts, joules, and ergs is not the total world, for the total world includes something like mentons. It should be recalled also that the thermodynamics laws apply to closed systems in a state of thermodynamic equilibrium. Well, defenders of mental causation can argue that at least some psychophysical transactions find the system neither closed nor isolated, and that in any case the real world is rather less tame than all of this would imply. Once we come to grips with the lives of actual creatures in the real world, the model of a closed, isolated system in thermal equilibrium would seem hopelessly innocent. The Nobel Prize-winning chemist Ilya Prigogine has drawn attention to this gap between the real, big, wide, and various world and the idealization of that world achieved at the level of theory. In the real world, systems are permeable to all sorts of external influences, such that there is ample opportunity for anti-entropic outcomes, outcomes in which disorganization is opposed by forces of organization, outcomes best described in terms of increased complexity and increased stability. Now, granted, this is surely a form of special pleading, but then so is the physicalists' promise that at some future time, when more is known about matter, physicalism will be vindicated. That, too, is a form of special pleading. It is sometimes suggested that evolution itself violates at least the entropy version of the thermodynamics laws, for through evolution there is a progressive increase in complexity and organization. At the level of the individual organism, the same seems to apply in that over the course of a lifetime, at least the larger creatures, including ourselves, acquire information, become more coordinated in their activities, more stable and settled in their lives, less random in their activities. There is an enchanting, if somewhat Gothic picture of all this, in which we find ourselves on a narrow bridge between an earlier universe of mindless and maximum entropy and some ultimate universe just as mindless, just as maximally entropic. But here we stand, growing in knowledge and order, thereby making our own tiny little contributions to the overall forces that might, at least for a time, hold things together. I say this is an enchanting picture. The daily headlines offer a different picture, alas. Well, I better stop with this before I lapse into punditry. But let me get to something even more daring: the prospect of consciousness and quantum physics being in some unexpected way interdependent. From the earliest days of quantum physics, one of its most influential schools, the so-called Copenhagen School, argued that the results of experiments at the level of particle physics can only be understood in terms of the influence of the act of observation itself. The names most closely associated with this interpretation, notwithstanding to the contrary their disagreements with each other, are Niels Bohr and Werner Heisenberg. Bohr's model of the atom replaced the tidy picture of a large nucleus with nice round electrons revolving around it as if this were a miniature solar system. Instead, the Bohr atom restricts the locations that electrons can occupy when moving from one orbital plane to another. Indeed, their positions are entirely probabilistic, as are the energy level transitions themselves. Even this model proved to be too stable to account for the growing number of experimental findings contradicting it. Further theoretical developments, driven by experimental results, present a microcosm in which the particles occupy multiple states and multiple locations at the same time. The very act of measurement now collapses these to a single state, which is to say a now specifiable single location and state brought about by measurement. Soon, and based on these considerations, quantum physics and consciousness began to form an odd couple in the learned discourse of the thinking classes. Eugene Wigner, one of the truly dominant figures of 20th century physics, speculated soberly on this connection between consciousness and quantum physics. The American-born physicist David Bohm, who died in 1992, who had been an associate of Einstein's at Princeton, pressed on with Wigner-type speculations and applied the theoretical and observational aspects of quantum physics directly to functions of the brain and to the problem of consciousness. I should say that David Bohm's is not a uniformly happy story, for he was caught up in the McCarthy hearings of the 1950s. His refusal to testify on Fifth Amendment grounds led ultimately to the termination of his Princeton appointment and his subsequent emigration to Brazil, where he came to chair the physics department at Sao Paulo. Well, let me stay a moment longer with Bohm's line of reasoning, if not his politics. His unusual gifts as a physicist became widely recognized when, with his student, Yakir Aharonov, he showed that an electromagnetic field could have effects in otherwise fully shielded regions of space. This, the so-called Aharonov-Bohm effect, which violates the core canons of classical physics. Their published paper in 1959 contains this tantalizing passage, quote, "Contrary to the conclusions of classical mechanics, there exist effects of potentials on charged particles even in the region where all the fields, and therefore the forces on the particles, vanish," close quote. Bohm later pulled together the theory and mathematics of the hologram and advanced the thesis that the brain, at the micro level, at the quantum level, is an informational system such that the mental and material merge. In an interview later published in 1986, he stated that matter and mind, quote, "are two aspects of one whole and no more separable than are form and content. Deep down, the consciousness of mankind is one. This is a virtual certainty, because even in the vacuum, matter is one. And if we don't see this, it's because we're blinding ourselves to it," close quote. Well, David Bohm was one of the few who could take on a problem as complex as that of unifying the physical and the mental. He wrote at length on the problem, one of the more accessible of his works being a book he wrote with David Peat titled Science, Order, and Creativity. It is no mark against his efforts to note that the efforts are purely conjectural, and that in a domain as rich in bramble and illusory paths as this one, speculators have things pretty much their own way. Bohm himself, partly through the influence of his wife Saral, came to see quantum physics as also compatible with Buddhist thought. But here again we can applaud the passion to know, even while cautioning against tendencies toward the exotic. I think the very achievements of modern physics have made all of us skeptical toward what? Skeptical toward skepticism. Just as we had become comfortable with the orderly and mathematically framed world bequeathed by Newton and his contemporaries, well, along came the new physics and turned everything on its head. What more stable principle of logic than the impossibility of something not being itself? And then physicists give us the pairing of little matter-antimatter items whose states are simply indeterminable. The net effect of these revolutionary and unsettling discoveries has been to all but eliminate the expression, "But surely you are kidding." As I say then, we are far less confident in our skepticism than were our ancestors of the previous several centuries. Well, would I be urging then the recovery of healthy skepticism? Of course I do. There's a great deal more to say about mind and matter, physics and consciousness. And unless all the theoreticians become Trappist monks, we can be sure that what needs to be said will be said. Now, I don't enjoy membership in the august club of theoretical physics. I, as with many others, can do little more than peek through the windows and hope to catch a glimpse of what's being fashioned therein. One must be mindful, however, of the natural tendency to impute special powers of discernment to those who seem to understand fully what one scarcely comprehends at all. It's as natural as taking seriously what a great athlete or some admired actress might have to say about foreign policy or the space program. Suppose the Copenhagen interpretation is correct. Suppose it actually is the case that only by way of observation and measurement, by way of the introduction of some element or derived product of consciousness, that quantum uncertainties collapse into determinate states. It's quite obvious that the conscious element in all of this could be supplied from persons walking on the moon, as by those making measurements of quantum states taking place in a laboratory in Switzerland. In other words, the influence that consciousness or its derivatives might have is not by way of contact, but by way of that dimensionless entity, information. It would seem that even granting all this, even adopting the Penrose model of just how mental states result in the collapse of the wavefront or some such, we've come no closer to solving the problem of consciousness than we were a century ago. Still unsettled, I am inclined to say still unaddressed, is the very nature of consciousness, the uniqueness of its possessor, the relationship to more specific mental states and functions. There's something else that I find, if not worrisome, then at least peculiar. The very essence of quantum phenomena is statistical. What quantum physics overturned, at least at the level of microphysics, is the classical world of absolute space, absolute mass, absolute motion. The very essence of mental life, however, at least at the level of normal adult human life, is the capacity for logical modes of analysis and argument. Modes of analysis and argument capable of achieving logical certainty. Capable, that is, of comprehending the broad divide that separates all that is merely probable from that which is logically necessary. But just in case the right model of brain function is finally to be developed within the framework of quantum physics, then the right model of brain function will be statistical from top to bottom. The relaxation of wavefronts won't help here. For the conscious comprehension of logical necessity simply will not match up with anything that is itself and intrinsically wholly probabilistic and contingent. The world of quantum physics is a world of pure contingency, the world of formal logic one of pure necessity. Although I'd not be so bold as to suggest, let alone declare, that ne'er the twain shall meet, I note the modal mismatch. This mismatch between the probabilistic nature of quantum reality and the necessities attaching to the conscious construction of such abstractions as mathematics and logic. To this I might add yet another perplexity, though there are surely dozens more that might be added. Quantum effects, owing to their statistical nature, become more accessible at the level of observation in the form of averages arising from innumerably large events at the level of particles. The brain, of course, possesses billions of neurons, comparably innumerable connections among them. At any given time, we might consider the functioning brain as the averaged outcome of all these small activities. But we are not the sole possessors of brains, and if some sort of averaging of large numbers of small effects is what is to get us to consciousness, it would seem that nearly any brain will do. For that matter, any bit of excitable tissue should do. I'd be inclined to say that anything complex enough to be alive would do. Is it all that odd, then, that when the Prince of Wales thought it advisable to speak to plants, he might have been up to something? I suspend my skepticism for the moment.